Hi, it's Jan Beta, and today we're going to take a look at the 1351 Commodore mouse for the Commodore 64 and Commodore 128. And I have the Commodore 1351 demo disc booted up here, and this is one of the demos. And it should actually move the little pointer you can see there, but it doesn't. It's just shaking a bit when I move the mouse. And yeah, there's obviously something wrong with it, unfortunately. For those of you who don't know, the 1351 is a proportional mouse actually that uses the pedal inputs of the SID chip in a quite clever way to provide a real mouse input for the Commodore 64. And they look very similar to the Amiga tank mice. And there's also a 1350 mouse, I think, which is like a joystick mouse that just emulates a joystick. You can put this into 1350 mode by holding down the right mouse button, if I remember correctly, while powering up the system. And then it's like it behaves like a joystick, kind of. When you roll in a direction, it simulates a joystick movement in that direction. So that's a very nice little mouse. I actually had one back in the day, and these are really rare these days. Actually tried to find one for quite a while and looked around eBay and actually found some Amiga mice that were advertised as 1351s, which obviously weren't 1351s, and finally found this. Was sold as being an unknown condition, and of course it seems to have issues. So what I'm going to do today is to take a look inside and just see if there's anything we can do. I think it uses a quite proprietary chip for providing the mouse signals to the pedal inputs or the joystick port input, and then through to the SID chip. So if that one is broken, we're probably out of luck, because it's not going to be easy to find a replacement for that. But I thought it would be interesting to look inside this anyway, so let's just do that. Let me take a couple of seconds to thank my sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs. They offer excellent service and great quality circuit boards with very fast turnaround times, global delivery. So if you have any projects coming up involving prototype PCB manufacturing, I highly recommend checking out the link in the video description and giving PCBWay a try. So yeah, this has 2 screws and the rest of it is clipped. I think actually looks clean. Seems to have been cleaned at some point before they sold it. Okay, let's remove the screws and look inside. I need a bigger screwdriver. Okay, that felt as if maybe this hasn't been opened. Yeah, there's still some plastic debris on there, so that might be a hint to this not having been opened before. So let's see. Let's hope for the best, I guess. Yeah, this is an old school mouse. Okay, the buttons seem to be in good condition. So the way this works is actually these wheels. There's of course a ball, like all old mice had, and there are 2 axes that are being turned by the ball if you move the mouse around. And then there's optical sensors actually. That's a little circular plate that has holes in it. So if that moves, the optical sensors can actually detect that. And that's how the movement is translated to electrical signals, basically. So the first thing I want to check, obviously, is if we can move the mouse pointer by just moving these wheels. Maybe just it's just the ball not making good contact, but I kind of doubt that. Yeah, and unfortunately we're getting the exact same behavior. The sideways motion is at least somewhat detected, but the up and down movement isn't detected at all. And if I remember correctly, this should only work in port 1, because that's the one connected to the pedal controls. Yeah, so we have to do some more work on this, I guess. So I can see 3 screws. This is a long one because it goes all the way through to the bottom case there. Another long one. Maybe they're all the same length. Would make things a bit easier. Okay, another one. And here's what's in here. Not much really. Couple of resistors. There's a quartz, 4 megahertz I think. And this is the custom chip Commodore software group, or MOS as it was previously called, from the 38th week of 1989. So this is a later model actually. So the first thing I want to try is to clean our little diodes, which I think are infrared diodes, so you can't really see the light. It's of course difficult to get in there, so I'm going to use compressed air. So there's 4 emitter diodes here. And there are phototransistors which are hidden in the black plastic parts. And yeah, basically the diodes shine a light through the discs with the holes, and if you move them, the resistance changes actually indicate the movement. So yeah, if anything is broken there or dirty, it won't register the movement. Let's see if that changes anything. And ta-da, we got the exact same behavior. Left and right movement kind of sort of registers, but up and down doesn't do anything at all. The buttons actually both work. So it says wrong if I click on the wrong thing for both buttons. So that's correct. Yeah, we should check if the cable actually has continuity. So maybe that's just a wonky cable. So I have strapped in the DB9 connector of the mouse here, and I'm going to use one of these plugs because it's easier to measure. And then I'm just going with my multimeter and check continuity to the PCB actually. And while researching 1351 repairs, I came across the monkeyspeak.com website, where Tom, the author of the website, has excellent schematics for this Revision A board. That's the same board I have, and he describes how he was able to fix his 1351 mouse. And I suspect I have a similar problem, but more about this as soon as I have checked continuity and some other things. Also some things that he suggests. Can highly recommend the website. I'm going to link that in the video description anyway. So yeah, he has a schematic for the output and which color wire goes where. Let's see if that's the same wiring that my mouse has. So I've set the multimeter to continuity testing, obviously, and we should have our green wire coming here. We should have our yellow wire coming here, which we do. Orange one. That's alright. The red one. Brown. Black. White. Violet. And the shield, which is probably connected somewhere to the shield. Yes, okay. So our connections are all there. All the 9 wires are connected actually, because it uses both the pedal inputs on the joystick port of the C64 and the joystick ports, because it has the joystick emulation mode, as I pointed out earlier. So yeah, all the wires have to be connected for it to fully function, and they are. So our problem is somewhere else. Surprise. I was actually expecting this to not be an easy solution because none of the directions work correctly. So here's the monkeyspeak.com website by Tom that I mentioned, and it's an excellent walkthrough of the whole process he did to repair his mouse. And yeah, there's some really useful information on here. The little quadrature encoders that they are actually. There's a little LED, like I pointed out, and there's a sensor, a phototransistor in this black housing here. And the LED is supposed to shine the light through to the phototransistor, and on the other side the same thing. And both of these determine the movement, or convert the movement of the wheels to electrical signals that the chip can then interpret and give to the Commodore 64. Here's another thing that he did that's very good for troubleshooting. To determine if the LEDs actually work, you can use the camera, because the camera can see the infrared light that these emit. That's one thing I also saw on Gadget UK's video, who did a video about 1351 repair a while back. I'm going to link that in the description and in the corner there as well, because he did another approach to the same problem, I think, and I suspect that might be the problem here. Tom found that there are resistors. Let me show you on the PCB actually. So there's a row of resistors here. Tom found out that while researching in forums and all the usual suspects sites for retro computing repairs, he found out that on many 1351s there were different values for the resistors. And these resistors are actually pull down resistors for the signals coming from the phototransistors. So these are connected to the phototransistors and bring the signal to a logic level that the chip can actually interpret as on and off. So the signal has to go from a logic 1 to logic 0 for the chip to be able to interpret the signals. And what these do is to make up for manufacturing differences, like differences if the plastic is warped or the light can't shine through fully, and you make up for the values that the transistor actually gets. So it might be that the LEDs degrade to an extent, it might be that the plastic warps to an extent. There's a very tiny hole, and Gadget UK points that out in his video in great detail, so I recommend watching that if you have the same problem or a similar problem. And he actually modded the case a bit and the housing of the phototransistors and widened the holes in these plastic parts. And he actually changed the position of the LEDs slightly and angled one of them so that it would shine in a straight line through the disc. I'm going to go with the method that Tom used. What Tom did was to measure the highest output he could get from the phototransistors through the resistors, and some of his inputs were not really a logic high, so he had some being at 1.7 volt. That's not going to be interpreted as a logic 1, so 4.7, 4.6 is okay. As long as it's 4 volts to around 5.3 volts, it's an okay signal that is interpreted as a high level. So that's what's supposed to be the highest point in the signals. And he had this and managed to replace the resistors with some variable resistors and just fiddled around with that, monitoring the signals until he had signals that were at a logic high level that made his mouse work again. So yeah, I'm not going to build a variable resistor board like he did. I think I'm going to try for each of the outputs if my levels are correct, And yeah, maybe I'll come up with a method and then replace the resistors permanently, I think, because I think that the plastic warping, which allegedly is responsible for this behavior, so that the light can't shine through fully and you only get a lower voltage at the output. I don't think that that changes rapidly. It's just a matter of some decades probably that this was lying around. And yeah, I think I can get away by just replacing the resistors permanently. Should this be the problem? I suspect it is, because it seems to be a common thing. Gadget UK had the exact same problem and had the solution of physically widening the holes, and that fixed it for his mouse. First of all, I want to see if the LEDs shine at all. That's another thing that might have failed. So we're going to dim the lights and have a look. So here we are in relative darkness. I'm going to turn the C64 on so this gets powered up. And let's see if the LEDs actually work. Can we see some LEDs? It's really difficult to see. I actually had to use my DSLR because it wasn't very visible on my phone camera that I usually use. So yeah, as you can see, all 4 LEDs light up and are the same brightness if I get them in the right spot. Yeah, so these work as expected. Yeah, I guess that leaves us with the fault that Gadget UK and Tom had with their mice. And that's that the plastic has warped probably over the years, and the amount of light shining through the little holes in the discs is not enough to trigger the high levels. So we're going to check the resistors. The resistors in question are R6, R7, R8 and R9. There's one for each phototransistor, so 4 of them, R6 to R9, are the ones in question. And I'm just going to measure the voltage over the resistors while this is powered on and see if my voltages are off. So I've hooked them up to R9, which should be the resistor for one of these. And I'm slowly turning the disc, and we get around 2.5 or something maximum. Yeah, so that's off, I would say. R8 around the same, actually, a bit higher, 2.7 or thereabouts. R7 should be for the other wheel. Yes, it is. Oh, that's a bit higher. That's probably why we got rudimentary left and right movement. That's at 3.3. But you can see it just changes between 0 and the high voltage as I turn the little disc here. Yeah, so that might be interpreted as a high still at some points. 3.4 or thereabouts. And the other one. That's a 2.1. That's R6 actually. Yeah, that's definitely too low on all my resistors here. The voltage is too low. So I think what I'm going to do to remedy that is to build a little contraption where I have a variable resistor that I can set to a value and measure the voltage and see if I can get it to a voltage that is actually a logic 1. For each of these resistors, and then replace the original resistors with the values that I measure. So that's going to be a bit tedious, but I think it's probably the way to go. So I'm going to desolder the resistors, I think, and yeah, make a little contraption. So here's what I'm going to do. I'm going to solder a little 50k ohms variable resistor to this piece of perf board, and I'm also going to add a 1k ohms resistor in serial with it, and then connect the outputs to the actual mouse circuit board and removing the original resistors. And yeah, I hope this way I can figure out the correct values for each resistor. So that's going to be a fun little exercise here. The 1K resistor is to prevent this from shorting out, actually, so we won't short out the mouse. So originally the resistors used should be somewhere between 5 kilo ohms and 15 kilo ohms maybe. So here's my crude little circuit board that I made. Yeah, as I said, 50k ohms variable resistor, 1k ohm resistor, and in series, and one end is connected to this pin and the other is connected to this pin. So we are going to desolder the original resistors from the mouse now. There we go. And yeah, as I said, these are different value resistors. Actually, all of them are different values, I think. Yeah. So yeah, what I'm going to do is to put in a pin header. One end of this end is all connected together to ground. So we're only going to solder one pin header there and then change the other one around accordingly. So yeah, that's what I'm going to do. So as you can see, actually the pin spacing was enough to fit a 4-pin pin header, and this is the ground. So yeah, we have 2.54 millimeters pin spacing, so you can fit a row of pin headers there actually, which makes things easier. And then I'm going to use a DuPont cable to connect them. So my ground is going to be black. And then we should be able to set the resistor values, and I'm going to measure the resistance and the voltage. And of course we're going to have to power up the C64 for this, and so I'm just going to set this to approximately 5K for the moment, so it's like a medium resistance. And then I'm going to power it up and see if I can reach a peak voltage while turning the little wheels of around 4.5, 4.6, close to 5, slightly under 5 is what I'm aiming for, I guess, and make notes for every resistance value. So I suppose I could use another 5-volt source of some description for powering the mouse for this experiment, but I'm using the Commodore 64 because I have it set up anyway, and I added the little 1K resistor to not short anything out on the port. So let's see what we get here. Yeah, 0 volts. Let's see if we can find a peak here. That's around our peak. Let's see. Yeah, and I'm going with 4.6, 4.7 volts, I guess. Yeah, this should be good. And that's a resistance value of 38.7. So this is R9. So, all right. Yeah, and I'm just going to repeat this for all the other positions here. So I'll be right back, I guess. So yeah, that worked surprisingly well by just turning the discs really slowly until I found a peak. And these are the values I came up with. They are all different, as was to be expected. And I'm just going to use resistors that are close in value, I think. So yeah, we might not be spot on, but we're still probably going to be able to have it reach a voltage that is considered logic high. So yeah, let's find some resistors for this and desolder our pin headers and solder in resistors with these values, or close to these values actually. So I found some resistors that pretty closely match my values here. And I went by the values that I measured actually with the same multimeter I used to measure the other resistances. So we should be pretty close, hopefully. I'm just going to solder these in and yeah, then test it, I guess. Okay, rechecking the voltages. Yeah, so 4.4, 4.6, okay. 4.2 should still be 4.8, okay. So we're pretty close to what we had when we tried this. The other direction. 4.8, nice. Yeah, 4.7. So yeah, this should actually do the trick, I guess. Haha, let's see if the mouse actually works. I have high hopes for this. Please don't let this be a disappointment. Okay, it works in this direction, works in this direction, it's in this direction, and it works in the other direction. Yay! Fixed it! Yeah, so that's, I guess, an elegant way of doing this. And yeah, I have to take this apart again to thoroughly clean the case, but I'm not going to do that in this video. Always want to turn the screw left a bit until it clicks into the actual threads, so you don't damage the plastic more than necessary. It's been a while since I cleaned one of these. So there we go. Should probably work now. Okay, I'm actually booting up a GEOS, which is, of course, in case you don't know, the graphical user interface that was at times sold together with the C64. And this should be set up, yes, to use this mouse. And it works beautifully. That's great. It's not a great mouse, but it's awesome that I can now use GEOS with the mouse again, just like I did back in the day, actually. I actually used it with a joystick before I had the mouse, but the mouse made things so much better and easier to use, of course. This is awesome. And it actually has some mouse acceleration too. Yeah, we fixed it. I fixed it. I hope this was useful for somebody. Maybe you have the same problem. This seems to be a pretty common problem with these mice. And yeah, that's the way to fix it, obviously. And I'm going to link the stuff I used in the video description as usual. Yeah, I hope you found this informative and entertaining. And as usual, many, many thanks to everybody who supports me, be it on Patreon or in the YouTube community membership is what it's called, I think. Thank you so much, and hopefully see you again on this channel sometime. Thanks for watching. I'm Jan Beta. See you next time. Bye. Excuse the moiré effect. I have this hooked up with the composite out through my cheapo upscaler, so it's not the best picture quality. But this video was about the mouse moving, so here's the mouse moving. It works again. Very nice.